On today's video, we're going to use a special product, which is sum and difference of two terms. To solve for the sum and difference of two terms, or SDTT, we write it as quantity E plus 3, quantity E minus 3. This is our easy question. To solve for this using SDTT, we follow the following steps. First, square the first term. It then becomes quantity E squared. Second, square the second term. It then becomes quantity 3 squared. Third, take their difference. It then becomes quantity E squared minus quantity 3 squared. The final answer then is e raised to the second power minus 9. That is the answer to our easy question. Now, for our average question, we write it as quantity 4a raised to the second power plus 2 quantity 4a raised to the second power minus 2. To solve for the SDTT, we follow the following steps. First, square the first term. It then becomes quantity 4a raised to the second power squared. Second, square the second term. It then becomes quantity 2 squared. Third, take their difference. It then becomes quantity 4a raised to the second power squared minus quantity 2 squared. The final answer then is 16a raised to the fourth power minus 4. For our challenging question, we write it as quantity z plus k plus 10 and quantity z plus k minus 10. To solve for this problem using SDTT, we follow the following steps. First, square the first term. It then becomes quantity z plus k squared. Second, square the second term. It then becomes quantity 10 squared. Third, take their difference. It then becomes quantity z plus k squared minus quantity 10 squared. Now, as you can see, quantity z plus k squared can still be solved using another special product, which is square of a binomial. And to solve for the square of a binomial, we should follow the following steps. First, square the first term. It then becomes quantity z squared. Second, solve for twice the product of the first term and the second term. And third, square the second term. It then becomes quantity k squared. The final answer then for the square of a binomial is z raised to the second power plus 2zk plus k raised to the second power. And your final answer for this problem then is z raised to the second power plus 2zk plus k raised to the second power minus 100. That is your final answer for our challenging question. We're done with special products. Our next lesson is all about factoring, and we're going to focus on DTC, or difference of two cubes. Our first problem is 8 over 27 minus 1 over 64k raised to the third power. Now, how are you supposed to know if you can solve this problem using DTC, or by factoring it out using DTC? Well, there are several conditions, and the first condition is that it has to be a binomial. And let's see, is it a binomial? Yes, so check that. Second, it has to be separated by a minus sign. Is it separated by minus sign? Yes, it is. So check that too. Third, its terms have to be perfect cubes. Check again. Are its terms perfect cubes? Yes, so check that too. Once you're done and sure that all the conditions were successfully met, how will you perform DTC? Well, first step is solve for the cube root of the first term, or solve for the cube root of 8 over 27. Second, solve for the cube root of the second term, or solve for the cube root of negative 1 over 64k raised to the third power. Once you've calculated that, you're left with quantity 2 over 3 minus 1 over 4k. But that isn't your final answer yet, because DTC's counterpart is product of a binomial and a trinomial factor. To solve for the final answer using DTC, you're also supposed to solve for the trinomial factor. So how are you going to solve for the trinomial factor? First step is square the first term of the binomial factor. You're then left with 4 over 9. Second step, solve for opposite the product of the first and second terms of the binomial factor. You're then left with positive 2 over 12k. Third step, solve for the square of the second term of the binomial factor. You are then left with positive 1 over 16k raised to the second power. And as you can see, 2 over 12k can still be simplified. So let's simplify it. You are then left with the final answer of quantity 2 over 3 minus 1 over 4k and quantity 4 over 9 plus 1 over 6k plus 1 over 16k raised to the second power. This is now your final answer for our first question using DTC. Now, for our second question, we write it as 1000j raised to the 12th power minus 8.64. Let's recall. What are the following conditions that a problem must meet in order to be factored using DTC? Well, again, as I've said before, the first condition is that it has to be a binomial. And obviously, it is a binomial, so let's check that off our list. Second is that it has to be separated by a minus sign. And yes, it is definitely separated by a minus sign, so let's check that too. Third is that its terms are supposed to be perfect cubes. And yes, its terms are perfect cubes. So let's check that too. Now that you are certain that all of the conditions were met in order to factor using DTC, what are the steps that you must do in order to factor using DTC? First step is that you have to solve for the cube root of the first term, or solve for the cube root of 1000j raised to the 12th power. Second step, solve for the cube root of the second term, or solve for the cube root of negative 8.64. After you are done calculating, you are left with the answer of quantity 10j raised to the 6th power minus 2.3. Again, this is not yet your final answer because the counterpart of DTC is product of a binomial and trinomial factor. To be able to get your final answer, you are also supposed to solve for the trinomial factor. To solve for the trinomial factor, the first step is square the first term of the binomial factor. Then the second step is solve for opposite the product of the first and second terms of the binomial factor. Then the third step is solve for the square of the second term of the binomial factor. You are then left with the final answer of quantity 10j raised to the 6th power minus 2.3 and quantity 100j raised to the 12th power plus 23j raised to the 6th power plus 5.29. I hope you've learned a lot. Tune in till next time.